This is the first video for Chapter 4 on sketching graphs and doing graph transformations. In Chapter 2, you looked at sketching quadratic graphs. In this video, we're going to look at sketching cubic, quartic, exponential and reciprocal graphs. Now remember, when you sketch graphs, you need to think about three things. First of all, the shape of the graph, and secondly, where the graph crosses or touches the x-axis, and thirdly, where the graph crosses the y-axis. So we're going to start with cubic graphs, and cubic graphs usually are in two forms. They're either positive cubic, which looks like this, or a negative cubic, which looks like this. Positive cubics, when you're sketching them, usually start down in the third quadrant and end up in the first quadrant, and negatives usually we start drawing it in the second quadrant, coming down to the fourth quadrant. There are slight differences in some of the cubic graphs, but when we come across those, we'll look at those. So we're going to look at the first one. So we're going to start by sketching the graph y equals x minus 2, 1 minus x, and 1 plus x. So the first thing we're going to do is consider the shape of the graph. Now if you look in the highlight, we've got x times negative x times positive x. Therefore, if you do that, x times negative x times positive x will give you a negative x cubed. So we know the shape should look like that. The next one is the roots, or where it crosses the x-axis or touches the x-axis. We'll talk about that in a minute. And that, of course, is when y equals 0. So it's what value of x will make each of the brackets 0. So you can see that's going to be x equals 2, x equals 1, and x equals negative 1. The last one is the y-intercept. And the y-intercept, of course, is when x equals 0. So if you put x equals 0, you can see, and I'll just highlight that in red, you're going to get negative 2 times 1 times 1, and negative 2 times 1 times 1 is negative 2. So you've got y equals negative 2. So we're going to start to draw that graph. So we know the shape, we know where it crosses the x-axis, of course, because you've got three different x values. So that tells you that it cuts the x-axis. This graph cuts the x-axis at 2, 1 and negative 1. So I'm going to put those on. So I've got negative 1, I've got 1, and I've got 2. And I need a graph that looks the right shape. So I said it starts, when we draw it, come down from the second quadrant, come through, cross through at 1, down through at 2, and that's what it looks like. And of course the y-intercept is negative 2, so make sure you put that on. Right, we'll have a look at the next one. Again, we're going to consider the shape. Again, I'm going to highlight that. So we've got x times x times x. X times x times x will be positive x cubed. So in other words, you know the shape it looks like. Our x, our roots, remember, when y equals 0, so you've got x equals 0, x equals negative 1, and x equals negative 2. Now, because one of the roots is x equals 0, we know straight away that the y-intercept will be y equals 0. Because if you set x equals 0, the whole thing will equal 0. So we're going to pop that information on. So negative 1 and negative 2. We know the shape. So it comes up from the third quadrant. Looks a bit like that when you draw it. Okay. Right, now when we're drawing curves, we need to look at certain things. So we're going to look at this one, and this is has quite a key learning point. Again, let's think of the shape. So we've got x squared times x. So the shape is a positive x cubed. therefore my shape is x cubed. So this is going to look like this. Okay. Now, if you were to write your function with 3 brackets, x minus 1, x minus 1, and x plus 1, I've just written it underneath, our roots are x equals 1, x equals 1 again, and x equals negative 1. So there are actually 3 roots. All cubics have 3 roots. Some of them are repeated, some of them are what we call complex sometimes. This one has 3 roots. Now you notice that those 2 are what we call a repeated root, and that gives us a key feature on the graph. So I'm going to mark the roots on. So we've got negative 1 and 1. Just work out what the y-intercept is. So the y-intercept, remember, when x is 0, so you get negative 1 times negative 1 times 1, which of course is 1. So we're now going to draw it. Notice we've got a repeated root at 1. So it's positive x cubed, so it doesn't cross through, it just touches the graph at 1. And that's the effect of the double repeat. Okay, and we know that this point here will be 1. Okay, now let's have a look at this next one. So we've got y equals x cubed minus 2x squared minus 3x. So the first thing I'm going to do is I'm going to factorise it. So y equals x. And you can all factorise, we're very good at factorising. So if I was to factorise that, that gives me x, x minus 3, and x plus 1. I pulled out x as a common factor and then factorised the quadratic that was left over. So I can see straight away the shape will be an x cubed, positive x cubed. Okay, my roots are x equals 0, x equals 3, and x equals negative 1. Because one of the roots is x equals 0, therefore the y-intercept will also be y equals 0. Okay, 3 different roots, so I'm just going to pop those down. So I've got negative 1, 0, and 3. I know the shape, and up it comes. And this is what it looks like. So when an examiner is marking these, this is what they're looking for. Now, if you look at this one, that's y equals x minus 2 all cubed. So we could write that as x minus 2, x minus 2, x minus 2. Okay. Now, therefore, the shape is an x cubed, positive x cubed, but this is a bit of an oddity. It's actually not going to look like that. We'll discuss why in a minute. Okay, our roots are x equals 2, x equals 2, x equals 2. So I've got one root there. Because it's a positive x cubed, it will start down in the 3rd quadrant, it will finish up in the 1st quadrant. Okay, my y-intercept, of course, is when x equals 0, so you get negative 2 all cubed, which gives you negative 8. Now this is quite important. If you look, you've got 3 repeated roots. You've got an odd number of repeated roots. And if you've got an odd number of repeated roots, you get what's called a point of inflection. And a point of inflection is where the graph goes just instantaneously flat at that point. So instead of being one of our normal x cubes, this one comes up like this. Oops, apologies. Pen comes up, it just goes flat and then goes back up here. So this point here, that is the y-intercept at negative 8, and that's what it looks like. Now again, it's still a cubic, but it's in the form, you all know what y equals x cubed looks like, and that's this type of graph. Okay. Now this one, if you have a little look at this one, it's y equals x minus 1 and then x squared plus x plus 2. Now this is a bit of an odd one. It is an x cubed graph. Again, it's going to be one of the ones where it doesn't, the shape is not, it is a positive x cubed, but it's not the shape, and you'll see why in a minute. Okay, you can see that our roots are x equals 1. If you try to solve this quadratic, you'll notice it doesn't solve, or not in real mathematics. So we've only got one root. One root, of course, that's where it crosses x-axis. So it will cross through at 1. The y-intercept, if you set x equal to 0, you're going to get -2. So it crosses through at -2. So it actually looks like this. This is -2. So you can see it's a very elongated cubic. You can see it's changing direction twice. If you're driving a car along it, it go right, then left. It's a bit of an oddity, this one. Right, we're going to look at this exam question. And this exam question says, the diagram shows a sketch of curve C with equations y equals f of x. Curve C passes through the points -1, 0 and touches the x-axis at the point 2, 0. The curve C has a maximum at the point 0, 4. The equation of the curve can be written in this form, and you're given the form. There it is. Okay, and we need to find A, B and C. So let's look at key things. We're told that the curve passes through the point, so it intersects at -1, 0, and it touches the x-axis at point 2. Now that then tells us about our roots. Our roots are x equals -1, x equals 2, and x equals 2. Again, remember we said a cubic has 3 roots. Some of them are repeated, occasionally they are what we call complex, and therefore it doesn't touch. This one, therefore we can say that the brackets that those roots must have come from must be x plus 1, x minus 2, and x minus 2 again. Of course, if you were to multiply that out, you will get y equals x cubed minus 2x squared plus 4. And if you compare that with your form, you can see therefore A must be -3, B must be 0 because there is no x term, and C is 4. Okay, right, now we're going to look at quartic graphs. Now again, quartic graphs have a certain shape. Usually a quartic graph will look like that. That's a positive one, so it starts in the second quadrant, it finishes in the first. Or a negative quartic look like that. Okay, a bit smoother than I've drawn it, but occasionally you'll get one that looks a bit like a quadratic. Okay, so a U shape, although the bottom of the U will be a lot shallower, or an N shape, and again the top of the N will be a lot shallower. So let's just have a little look at these ones. Again, the same features apply. Roots, if you've got different roots, that's where it crosses the x-axis. If you've got repeated roots, a double repeat, an even repeat, means it touches the x-axis, and an odd number of repeats means you've got a point of inflection on the x-axis. So again, if we have a look at this one, you can see it's x times x times x times x. Therefore, the shape is a positive x to the 4, or quartic. Okay, so therefore it's going to look a bit like a W. Our roots, I'm going to write these down, our roots are x equals -1, x equals -2, x equals 1, and x equals 2. So I'm going to mark those on. -1, -2, 1, and 2. And again, our y-intercept, remember that's when x equals 0. So it's 1 times +1 times +2 times -1 times -2. So that will give you y equals 4. So I'm going to draw it. And remember that the roots are all different, so that's where it crosses. So it crosses through at -2, crosses back through at -1, crosses back through at 1, and then back up at 2. And of course, your y-intercept is 4. Let's have a look at another one. And again, this one, just be careful, think of it, the things we talked about before. Again, this time we've got x times x squared times -x. So the shape be a negative quartic. Okay, our roots are x equals 0, x equals -2, x equals -2 again, and x equals 3. Again, you've got the repeat, so that means it just touches the x-axis at that point. So let's put those on. So it's 0, 3, and -2. Again, because one of our roots is x equals 0, then the y-intercept will also be y equals 0. So it's a -1, so it starts in the third quadrant, it comes up, it touches the x-axis, it must not cross through the x-axis, negative must touch, then it comes up, crosses through 0, and then crosses back through 3. This one, if you look, the shape is x squared times x squared, therefore it is a positive quartic. So it's going to look like a W, elongated W. Our roots are x equals 1, x equals 1, x equals 3, and x equals 3. So you can see we've got a double repeat. So we're going to just be touching at those points. So 1 and 3. And of course your y-intercept and x equals 0, and your y-intercept therefore is going to be 9. So it's a positive one, so it comes down on the second quadrant, comes down, touches 1, comes back up, touches at 3, and then it's there. And we know that the the y-intercept is 9, so we're going to fill that one in. Okay. Right, now we're going to talk about reciprocal graphs. Now again, reciprocal graphs have a certain shape. Okay, we'll discuss the shape. Usually, reciprocal graphs will look like, so k over x, and this is the axes, they will look like, so usually in the first and third quadrant, if k is positive, if k is negative, it will be in the second and the fourth. You could also have k over x squared. Again, if k is positive, it will look like this. Okay, and if k is negative, it will be in the third and fourth quadrant. Okay, so we're going to look at some sketches. So the first one is 1 over x. Now you can see very clearly that using basic mathematical concepts, you cannot divide by 0. So x cannot equal 0. Therefore, the line x equals 0, or the y-axis, is what we call an asymptote. And it's spelt as an asymptote. In other words, an asymptote is a line that the graph comes very close to but doesn't touch. And we usually mark an asymptote with a dotted line. Sorry, a dashed line. So there's my asymptote. Okay. I'm going to draw my graph. It's a basic one. This is really one that you need to know. And this is what it looks like. So it looks like this. And you notice. Just make that a bit better because that's a bit rubbish. Okay. So we can say as x tends to plus or minus infinity, y tends to 0. So you can see the y value is going close. It never actually touches it. Okay. As x tends to 0 from the positive x side, then y will tend to plus infinity. And as x tends to 0 from negative x, y will tend to negative infinity. Now, what does that mean? Okay, so as x tends to plus or minus infinity, so in other words, as x gets bigger and bigger and bigger, the y value goes closer to 0. In other words, this line would come closer and closer and closer to the x-axis, but it would never actually touch it. The same here, as x tends to negative infinity, this line would come closer and closer to the x-axis, but never touch it. Same here, as x tends to 0 from the positive, so as x goes this way, you can see what's happening to the y value is getting bigger and bigger and bigger, so that is tending to positive infinity. And as x tends to 0 from the negative x side, so it's coming in this way, you can see what's happening. The y value is tending to negative infinity. So it's a good idea to think about what's happening. Now this one is 3 over x squared. Okay, again, right, x cannot equal 0. So therefore we've got an asymptote. X equals 0, so we need a dashed line. Now, usually, if your asymptote is one of your axes, you don't need to mark it. If your asymptote isn't one of your axes, you must mark it, but I've marked it on there. And again, you can see for every value of x, this would always be positive, so above the x-axis. And again, if I draw it, okay, this is what it would look like. Okay, and again, when you're doing a sketch, they're looking for shape. Now that never ever touches either the x or the y-axis. This one, again, you can see it's negative 3 over x. X can't equal 0, so the y-axis, or x equals 0, is the asymptote. This time, you notice we've got a negative in front. So this would look very similar to 3 over x, but it's in the opposite quadrant. So this will always be, okay, for positive x values, it will give you negative. For negative x values, it would give you positive. So in other words, instead of being in the first and third quadrant, this is in the second and fourth quadrant. So there they are. So remember, this is the second and this is the fourth. Okay, and again, never touches the axes. Okay. This one, again, very similar. It's negative 4 over x squared, so the negative, there it is, the negative. That means that instead of being in the first and second quadrant, it's in the third and fourth. So this one does something this up. We're just looking at the shape. This is what it would do. Okay. Now, the last thing we're going to look at is exponential graphs. And exponential graphs are very useful in mathematics. Okay. Now, the shape of an exponential graph is usually like that, depending whether it's a positive or a negative. This one, first of all, we need to find out if it crosses. Now, you would notice that this, for any value of x, 2 to the power x is always positive, therefore it's above the x-axis. And when x equals 0, y will equal 1. Okay, because 2 to the power 0 is 1. So this graph, oops, do that one again, looks like this, and that is 1. Okay, you can see that as x tends to negative infinity, okay, y will tend to 0, and as x tends to positive infinity, y tends to positive infinity. Okay, and we've got one more, 3 to the negative x. So again, if x equals 0, y will equal 1, because 3 to the 0, anything to the power 0 is 1. The shape of this one, it's because it's got that negative, and you can look at the pattern, but again, for all values of x, this 3 to the negative x will always be positive. Okay, so this comes to this, that is 1, and again, as x tends to positive infinity, y tends to 0, and as x tends to negative infinity, y will tend to infinity. And that's the end of this